So this is a question given in GATE 2020 electrical engineering paper, in which you have given xt as an input to a LTI system whose impulse response is h of t and output is y of t, and you need to find out that condition of mod of xt convolution with h of t. So the NPTEL reference for this question is Principle of Signal and System by Professor Aditya Jagannathan. You can find lecture video for this topic in this course. So the useful data for this question is that you need to know the convolution integral of LTI system. So if yt is output of LTI system whose input is x of t and impulse response as h of t, then this convolution can be given as minus infinity to infinity x of tau h of t minus tau d of tau. So in the question you have given that mod of x of t convolution with mod of h of t is z of t. So you need to find out the condition of z of t and y of t, whether z of t is greater than equal to y of t or less than equal to y of t, or what is the condition of t on which z of t is less than or greater than y of t. So you can write z of t as, and this is the convolution integral, you can write z of t as minus infinity to infinity mod of x of t into mod of h of t minus tau into d of tau, and y of t is given as minus infinity to infinity x of t into h of t minus tau d tau. So let's say if this is x of tau and it is also x of tau, so if any one of x of tau or h of t minus tau, if any of x of tau or h of t minus tau becomes negative, then your integral y of t will be negative. If both are negative, then y of t is positive. This is y of t as negative. Just more sums. If both are positive, then y of t becomes positive. But on the other hand, you can see that z of t will be always be positive, whether x of tau or h of t minus tau positive or negative? Z of t will be always be positive, and but y of t becomes negative when any one of x of tau or ht minus tau is negative. So from these two, you can see that z of t, when z of t is positive, then it is equal to y of t, and when y of t is negative, then z of t is greater than y of t. So you can write this one as when t belongs to minus infinity to infinity, then z of t will be always be greater than equal to y of t. When it is greater, when y of t becomes negative, that is the first condition. When x of tau or h of t minus tau, any one of x of tau or ht minus tau becomes negative, and z of t will be always be equal to y of t when y of t is positive, because z of t is always positive. So the correct answer for this question is option